Question 18. So first of all, name the constituent of the atom which has a zero charge. You either know this or you don't. You'll be very surprised if you don't by now. That of course is a neutron. Part 2 has the largest specific charge, so the largest ratio of charge to mass. Neutron has no charge, so it can't be that. The proton does have a charge, but its mass is quite big, so you'd be dividing by a bigger number. The electron has a very, very small mass, so it's going to be a high specific charge because the mass is small and the charge is still -1, still a big number relatively. So it is, of course, the electron. Part 3. When removed, leaves a different isotope of the elements. Again, that's our neutron. These are just things you're going to have to learn. There's no really working it out. Right, part B, we're given an equation. We've got 9943 technetium. It uses a radioactive tracer in medical physics. Decaying into something else. I'm not sure what that stands for. Rubidium, maybe. And releasing a beta particle and a mystery particle. So identify the particle X is our first job. It's beta minus decay, and the way to work this out is to see what's happened with lepton numbers. Now in terms of lepton numbers, this nucleus to start with has a lepton number of 0 because there's no leptons in it, as does this one. It's only the nucleus we're considering. This beta particle has a lepton number of +1. So in order to conserve lepton numbers, we've got 0 on the left hand side, we must have 0 on the right hand side, it must have something with a -1. Charge is already conserved. There's 0 charge on this side, there's 0 charge on this side. I mean, there's not really 0 charge because you've got your 43s and stuff, and I've just made a mistake, it's not 0 charge there, there's 1 extra charge on that side. That leaves a -1, so charge must be 0 in order for charge to conserve. And that leaves us with only really one option, which is going to be an anti-neutrino. Next bit, we need to identify what A and Z are. So A, this one up here, well, A is going to remain the same in beta decay. A neutron turns into a proton, so there's no change in the nucleon number, so that will be 99. And Z, well, in beta minus decay, a neutron turns into a proton, so we get 1 extra proton. That's simply going to be 44. Finally, running out of room, do it here. Calculate the specific charge of technetium-99 nucleus. State an appropriate unit for your answer. So specific charge is our Q/m. It's only asking for the nucleus, so I'm not going to take into account masses of electrons or anything like that. There are 43 over here, 43 protons, so that's 43 times the charge on a proton, 1.6 times 10 to the minus 19, divided by the total mass, which is going to be 99, times the average mass of a nucleon, 1.67 times 10 to the power minus 27. Run out of space. That's going to give me an answer of 4.2 times 10 raised to the power 7. Now the units, well, that's coulombs up here and kilograms down here, so that's coulombs per kilogram. Yeah, that's question 18.